Good afternoon, everyone. Thank you for your time for joining us with today's sessions. I'm Ihan. I'm an incident response consultant from Mandiant. And along with me is Sunpu. He is also an incident response consultant from Mandiant. So it's an honor for us to share a bit about some of the investigations that we have been performed in our day-to-day life. For today, we will be sharing one of the case studies where it started from a job interview and then moved to Crypto Heist. So firstly, I would like to share some disclaimer. So from some of the case studies that we will be sharing is based on some of our experience as well as investigations that we're working for a variety of customers. And what we will be sharing do not represent any information from either any single customers or a set of customers. In many cases, some of these facts has been altered or changed to obscure the identity of our customers, as well as individuals that's associated with our customers. With that, let's begin. So for the background is a crypto service provider in Asia reached out to Mandiants to support them in an investigations. What actually happened is within their environments, cryptocurrencies was being stolen from their wallets. Of course, the clients had performed an internal investigations, but they were still puzzled because they did not identify a compromise of their wallet private keys. With that, they have these key concerns, whether or not their environments is still safe for business operations. And from this, the investigation come up with some of the key objectives that needs to be answered. The first question is, how did the threat actors access the environment? Next, how did the threat actor steal those cryptocurrencies? Did the threat actor bypass some of their security controls to perform the crypto heist? And lastly, whether or not the customer's environment is still being compromised. Is the threat actor still within their environment? And of course, from these investigations, how can they improve their security postures as well as to prevent similar incidents from happening again? So with that, let's answer the first question. How did the threat actor access their environment? So for the threat actor, we have known that this threat actor is known to be using social engineering attacks to gain initial access into a victim's environment. In this case, the threat actor would first create a code repository on the public GitHub. Next, the threat actor would upload malicious code to the newly created code repository. Then, the threat actor would use messaging applications to reach out to previously identified targets, which we will call them as victims. The threat actor would first impose themselves as a recruiter from a renowned crypto company within the industries. They will share with the victim that there's currently an job opening available and how their portfolio seems to be fitting for the opening. The threat actors would entice the victim to accept the job opportunity and proceed with the interview process. And that part would require the victims to perform a candidate assessment process. Within the candidate assessment process, the victims would need to download the malicious code from the public GitHub repository and perform certain level of debugging and troubleshooting to pass the assessment. In this case, the victim accepted the job interview and proceed with the assessment. The victim itself is a developer as well as a super user. So the victim itself is a highly privileged user within the client's environment. So the victim then proceeds to download the malicious code and execute it on the company issue workstation. So one key part is that earlier I mentioned the victim is a developer. So for developers, usually they can be pretty tech savvy. And as they are performing the troubleshooting or reviewing of the applications, they may see some suspicious code or malicious code. In this case, the threat actor actually hide the malicious code within the libraries that will be used by the application. Thus, when the victim is reviewing the codes within the applications, they did not identify any suspicious or malicious code within the application. And one part for these activities, job interviews, doing the job interview part, we felt that the victim should not use a company-issued workstations to perform these activities. So once the victim has executed the malicious code on the company-issued workstations, a backdoor would be deployed onto the endpoint to establish foothold. Persistence will also be created for the backdoor. And once the backdoor has been executed, the backdoor would then reach out to the command and control server, which we will call as C2 server. With that, we have understand how the threat actor had managed to gain access to a company-issued workstations. For this part, the threat actors took about 3 weeks to gain the access to the workstation. So through the backdoor, the threat actors then deploy additional tools to further its attacks. During the reconnaissance phase, the threat actor was understanding how the user would behave in his day-to-day life and observed that the victim would use the password manager to manage credentials that will be used in his day-to-day operation. The threat actors also observed that the user, or rather the victim, would access certain servers in his day-to-day life. And with these informations, the threat actor will use credentials from the password manager, as well as some of the behavior that they have observed, and move laterally to the server environment. In this case, the threat actor first moved to the package manager server and deploy additional backdoor on the server. Once again, persistence will be created for the backdoor, and we felt that the threat actors would prefer environments such as the server to maintain their persistence, because for workstations, it will be subjected to the victim's working hours, as compared to a server who need to fulfill its purpose or requirements in a 24-hour. After the threat actors gain access to the package manager server, the threat actors once again perform reconnaissance to understand this new environment, the server environment. The threat actors have also identified that there were nodes being created by the victim on the package management server, which give them a quick understanding about what would be the victim's usual day-to-day behavior be like, as well as some of the servers and their functionalities. With that, the threat actors then move laterally to another server known as the code repository server. Once the threat actors has access to the code repository server, the threat actors have performed more reconnaissance and identified that there are available connectivity to container pods, to services hosted on container pods. The threat actors then identified that there are vulnerable services hosted on the container pods and exploited those vulnerabilities to gain access to the container pods. During our investigations, we have also identified that the threat actors has escaped from the container pods and accessed the Kubernetes nodes. In this case, the threat actor had access to the critical service known as the wallet service and accessed the wallet service nodes. Once the threat actor gained access to the wallet service node, it then uses the Kubernetes administrative tool to access other container pods. With that, we have identified how the threat actors move laterally from a compromised workstations to a critical server. For this part, the threat actors took about 48 weeks to gain access from the workstations to the critical server. With that, I'll pass it on to my colleagues to share more, to answer the other two questions.
Okay, thanks, Yihan, for the detailed sharing of how the threat actor accessed the environment from the foothold. Now we have two more questions left to answer. Second question will be, how did the threat actor bypass very tight internal controls and was able to transfer the money from the victims? And third question coming from the victim will be, am I still compromised, and how can I do to improve my security posture? But before we answer these two questions, I would like to give very basic introduction of how the crypto transaction work, because I know the audience may have a different background, and some of them may not be so familiar with the crypto transaction. So this one, I will share how the crypto transaction work. So as you can see here in this yellow box, this pertaining to the infrastructure managed by a crypto service provider. And outside of the box, we have 3 wallets. This pertaining to the wallet address on the public blockchain, which can be a Bitcoin and can be any other cryptocurrency. So we will think from a user's perspective, how do you deal with the crypto service provider? So I will take an example like a bank. Actually, there's not much difference when you deal with a crypto service provider versus when you deal with a bank. So just imagine yourself, you are a user, and it's your first time to deal with a crypto service provider, just like the first time you deal with a bank. What you need to do is, you need to open an account. And the same as the bank, you need to use a mobile app or maybe a web portal of the crypto service provider and open an account. Of course, after the account was opened, the backend server of this crypto service provider will update the user database. And this user database may contain all the data related to the user, like username, credential, and also the most important thing is the account balance. So after the account created, the account balance by default will be 0, and you will make your first transaction will be deposit. So you may need to deposit your money to your crypto service provider. But how do you do that? It's different from bank. Normally when you do it as a bank, you pass your cash, you pass your check to the counter, they will deposit the check into the bank account, and you will see the account balance change. But how do you do with the crypto service? So normally, the crypto service provider, they will create a user wallet. Of course, this wallet is not controlled by a user, it's controlled by the crypto service provider, but this wallet address normally will be unique. So they will give you the unique wallet address to the user, and user just need to transfer the money from their own wallet to this user reception wallet. And of course, the backend server of the crypto service provider will keep monitoring the change of the wallet balance. And if it detects the balance changes, the servers will update the user database correspondingly with the amount changes. And when the user logs into the web portal and mobile app again, he may see the balance increased. So that's how the deposit works. It's very similar to the process when you deal with a bank. And of course, I mean, when we deal with the bank, we also need to withdraw the money. But how does the withdraw money work? It's the same. The user needs to use the mobile app and web portal to access the crypto service and create a request to withdraw order. And backend server receives the request and will perform a series of the internal verification and check with the user database to confirm that the transaction is legit and user has enough balance to perform a withdrawal request. If all the verification has been passed, then the backend server will proceed to deal with the hot wallets, to transfer the money from hot wallets to the address designated by the user. So what is the hot wallets? You can consider it as the vault of the bank. So basically, the crypto service provider, they may have a long list of the hot wallets. And inside of those hot wallets, they have those crypto assets which used to back up their operations. So it's similar as a vault. If the threat actor has access to hot wallets, it's similar to the criminal has access to the vault. They can carry all the gold bar and cash from the vault. It's the same. So if the threat actor has access to the hot wallets with a private key, then threat actor can move all the crypto assets from the hot wallets. So that's a basic how the crypto transaction work. And next, I will go deeper into a backend server. Because just now from the previous diagram, we noticed that the backend server sits in between, and it becomes the role of the bridge between the database as well as other crypto wallets. So it plays a very important role here. So inside of the backend servers, actually, we have a cluster of servers plays different roles. Can be wallet server, can be signing server, can be verification server, can be broadcast servers. And of course, there are more. But just for simplicity, for this workflow, I will show some critical servers inside of the diagram. So this square here represents backend servers, and I will go through the process how a legitimate withdraw request within the backend servers. So we can start from the step 0, when the authenticated user create a request to withdraw money from the crypto service. So what normally they do is, from the front end, they need to send a withdraw request and will be passed to the wallet server. And wallet server will prepare all the information required to withdraw. For example, like the destination wallet address and amount of the balance to be transferred, and create a payload. But the payload is not signed yet, and this payload is not good to be broadcast yet. So the wallet server will pass all the information to another server called the signing server. Why they need a signing server? Because for crypto wallets, each wallet they have a private key. As just now I shared, for a crypto service company, they may have a lot of hot wallets, and every day there are thousands of users may need to create a withdrawal request, and they cannot do it manually. So of course they have these signing servers to perform the signing transaction. So a signing server is very important because it has access to the private key of hot wallets. So imagine if a signing server is compromised, that means this company, all the money of the company's hot wallet will be gone. And in our case study, this signing server is well secured and was not compromised, but money was still able to be transferred. So after the signing server performed the signing transactions, signing server knows that the transaction has not been reviewed yet, so it's not good to release. So it will encrypt the transaction with a symmetric encryption key, which is an AES key stored in some cloud key management service, and return the transaction encrypt to the wallet server. But the wallet server cannot do anything because it's encrypted. So it has to pass the encrypt transaction to another verification server. This verification server has access to the AES key and decrypt it and perform the necessary verification steps, which is to query user database and other authentication information to confirm the transaction is legitimate. And if so, verification will proceed the next step, which pass the plaintext payload to the broadcast server, and it will broadcast to the public chain, for example, like Bitcoin, which will complete the whole withdrawal transaction. So that is a normal, that is a process of the withdrawal authentication we observe in this case study. So maybe this one is not so straightforward to understand. So I will use another very simple example, like check. It's a financial payment method we deal with every day. Actually, the whole process is very similar as what we see here is a check. For example, if you have been working with a financial team, you may know that someone needs to prepare a check if they want to release a payment to their vendor, to their supplier. So what do they need to do when they prepare a check? They need to fill up the payee's name, they need to fill up the amount of the money to pay out. So that's all information they need. It's similar as what we do with the crypto. They need a destination wallet address, they need amount, and after the check's been prepared, they need another person to sign. That's so-called the segregation of duty in internal control, and it's the same. So we need a signing server to perform the sign, because the person who prepared normally is not authorized to sign. They need a higher level of management, like finance manager, to sign the check. And the finance manager signed the check, but finance manager is lazy. He doesn't want to perform any verification. So he delegates this duty to the third person. The third person, but he knows that the check has been signed, and it's very risky to just deliver the check to anyone because they may cash it. So they put the check into an envelope and encrypt it to the third person. And of course, the third person has access to the key. And the third person uses the key to open the check, to open the envelope, and read the check and perform the necessary verification steps, which including like you check versus your invoice, versus your purchase order to confirm the payment is legit. And after that, they will pass the check to maybe the postman and send the check to the bank. The postman can be our broadcast server. So the process is very similar. But if you are a very experienced professional and you deal with some so-called business process and internal controls, you may observe that there are some loopholes, but I will share later, and how the loophole was abused by the threat actor and result in the loss of the money. So just now the process was the process of the organization, but here in this new one, we have added the track actor in the map and share with you how the track actor bypassed the controls and was able to transfer the money. So actually the whole process, there was no change of the whole process, but there's only one change is the track actor has compromised the wallet server. After the track actor compromised the wallet server, what they can do? When they prepare the transaction, since track actor has compromised it, the track actor can also forge the transaction and prepare the withdrawal request. So that's what track actor can do. If track actor prepare the request and send to a signing server, will signing server sign it? The answer is yes, because that's how they design. Signing server just sign it, and it's not signing server's responsibility to perform the verification. So the signing server just sign it and pass back to the wallet server. Of course, as we know, the signing server has to use the AES to encrypt it and pass back to the wallet server. And since track actor has the access and compromise this wallet server, so the track actor has access to the encrypted transaction. But track actor cannot do anything yet. Can the track actor just let the wallet server continue do its work? And whether will the track actor get the money? Maybe not, because if the wallet server continue do the work, pass the encrypted transaction to the verification server, the verification server will decrypt the transaction and perform verification with the user database and other information, and the verification server will conclude that this transaction is forged. I will not pass it. I will reject the transaction. Then this forged transaction will stop here, and the track actor will not get the money. But track actor was smart because they know that they spent almost 1 year in the environment, and they read the design, they read the documentation, and they know that the key to encrypt the transaction is stored in some KMS in the cloud. And unfortunately, the victim organization, they have a very big cloud deployment, and there was some misconfigurations where there was a service account, had access to the AES key, was compromised by the track actor. Now, track actor have, on the left-hand side, the track actor have encrypted the transaction, which is signed. At the same time, track actor has access to the AES key to decrypt the transaction. That's everything they need. Track actor just download everything and decrypt the transaction, then they can broadcast by themselves. They can do it offline. They don't need all those verifications. They don't need a broadcast server. They can do it by themselves. So all those controls are filled if the track actor has access to this AES key. So that's how it happened. So the track actor forged several transactions, which they were able to transfer the money out of the hot wallet to their own wallets. But of course, the amount of the transaction was huge and was detected by the security professionals in the organization. But it was too late because transaction has already been made. Of course, they did some remediation controls. In the end, the track actor couldn't transfer all of the money from hot wallet, but still, the victim organization bear a very huge loss from this incident. So, but why track actor can do that? We realized that there is a verification process shortcoming. And it's not pure technical control. It's a business process control. So we realized that the verification flow was triggered after the signing process, which is not right. Because I mentioned earlier the example in the financial process. Normally, in the finance team, after the person who prepared the check, the second person must verify the transaction, verify the check, and confirm the transaction is legit before signing it, not sign it and the check. So that's a normal process we'll do. And also, because the signing machine just signs every transaction blindly, no matter the transaction is legitimate or not, will be signed. And in this case, the track actor, they have the access to the wallet key and to the AES key, and which because of the misconfiguration of the service account, that's what happened in the whole verification process. So after this analysis of the attack path, we have answered the second question, that how the track actor bypass the controls. Now the third question left is, are they still compromised, and what they can do to enhance their environment security posture. So actually, after this incident happened, of course, we need to do all the necessary work we do. We can perform all the scanning and well as the remediation controls to kick out the threat actor from the environment. Of course, they need to update their policy regarding KMS and to ensure, and also need to rotate the AES key. But more importantly, we also notice that they need to enhance their continuous monitoring of the endpoints. Because during the investigation, we noticed that they didn't have a established endpoint monitoring process. They didn't have an EDR, maybe because they believe that most of the employees, IT service, and they are they should be very cautious, but they were not. And also, they should perform some assessment in the environment to identify the evidence of compromise, especially to consider some like user behavior analysis. Because in this case, as Yihan just now shared earlier, the patient 0, he was a privileged user. He downloaded the code from GitHub, and all those activities may not be so malicious just based on the activity itself. But if with some level of user behavior, they may detect that it's not very Euro behaviors. And because this user is a super user, you should lower your risk appetite. So that may help you to enhance your security controls, as well as the cloud security assessment. The organization was using a cloud platform. They highly rely on the Kubernetes as well as the KMS, but they didn't do this kind of assessment, which resulted in there was a misconfiguration, and also tried to have access to a crown jewel assets. And Intel-driven threat hunting, because from this TTP you can notice that it's a bit different of the typical cybersecurity incident. So, and we know that the victim organization is the Web3 companies, is the crypto companies. And we also know that the threat actor was targeting this kind of the industry. And if they can do some level of Intel-driven threat hunting based on the threat actor's profile, maybe they can have deeper insight of their security evidence. And also, who is the threat actor? So based on our internal investigation and evidence, Mandiant tracks the threat actor as the UNC4899. And this threat actor is known as the North Korea Nexus threat actor group. And actually, we also work with our counterparties in other regions. We noticed that this threat actor, actually, they were targeting the Web3 companies. The reason is, if they can successfully compromise Web3 companies, they are able to transfer the cryptocurrency assets directly and get the money instead of like a ransomware need to negotiate. So this one is even though they took a long time, but they can gain a lot. So this is the profile of the threat actor. And also, we may want to know that what kind of takeaways we can learn from these case studies. So as I mentioned earlier, enhance the detection of endpoints. This thing is very basic for most of the big organizations, but we realized that for those Web3 companies, most of them, maybe the size is not so big. And most of the employees, they are quite technical. So somehow, they may ignore the importance of endpoint detection, even though it's some very basic thing for most of our cybersecurity professionals. And second thing is, they should consider improve the visibility of Kubernetes log. The reason was, we realized that for this organization, they highly rely on the cloud platform. They use Kubernetes almost for everything. So I know the Kubernetes is very powerful tool, especially for developers and the system administrator. It's very easy to deploy. It's very easy to scale up, and also it can automate the whole deployment process and easy to use and consume less resource. But for cybersecurity professionals like us, it may become a headache. The reason is for the Kubernetes nodes and pods, especially on cloud platform, it may self-destroy. For normal cybersecurity incident, if we don't have access to the network flow log, we don't have access to a firewall log, we still can do a full disk forensic. I mean, we can get a server, hard disk, we can get an image, we can do everything we need. But for Kubernetes nodes and pods, the life cycle is very short. Sometimes it can be just 12 hours. Of course, when we perform the investigation on those incidents, maybe already past the life cycle of the pods or nodes. So we may not be able to get the information from the server level, or from operating system level or container level. So it's important for the organization who relies on the Kubernetes, you should turn on all the necessary logs and make sure the coverage and the retention life are sufficient enough for you to perform investigation. Because if you didn't turn on the log, after an incident happened, we really have nothing to perform investigation. That's very important. That's plays a very important role. And cybersecurity awareness. I know this thing is not new. I mean, almost you may have heard about it almost 10 years ago. But this one, but it's still a problem. You can see from here. The initial compromise coming from the patient zero, who was using a company-issued laptop to run the code download from GitHub. I mean, there's nothing wrong for him to look for another opportunity. But please do not use your company-issued laptop to run a code challenge. If he used his own personal laptop to run the thing, maybe the threat actor will not able to establish a foothold. So that's cybersecurity awareness. And sometimes the organization, if they believe that their employees are technical, they may believe that they have cybersecurity awareness as well. But it's not true. You still need to continue to do the education to let them know that something they can do and something they cannot do. And the last thing, that is the most important part, is to review the critical business process with your stakeholders. So cybersecurity is never a standalone business. So it's not a single team job. You need to work with your stakeholders instead of your organizations, especially for critical business. Whoever designed the business process, you should sit with them together to analyze whether the cybersecurity can have any negative impact on the business process. And if there's any vulnerability, what you can do, and how cybersecurity people can help them. Keep reviewing, keep improving, and maybe it will help your organization better than this one. So I think that will be my last takeaway. I will wrap up today's presentation, and thank you for joining us, and we'll open the floor for a question. Yeah.